Okay, this is Dr. Williamson going over the first part of the molar volume of nitrogen lab. And I'm trying out a new microphone. Hopefully this will help. Okay, yeah. Okay, so what we're going to do is in this container, let me draw it. Here, draw. Boom. In this container right there, we're going to put, here, let me draw this. We're going to put 0.14 grams of sodium nitrite and 0.15 grams of sulfamic acid. And I just chose the nice perfect numbers of 0.1400, 0.1500. You won't have those nice perfect numbers, but they should be like 0.14, very close to 0.14, like no more than 0.1420 or 0.1410. And they should be no more than 0.1510, somewhere around there. And this experiment, these amounts are chosen such that the sulfamic acid is the limiting reactant. So we're going to base the amount of nitrogen produced based on the limiting reactant. So where I follow this blue arrow, I have that reaction go on in there. And at the beginning of this reaction, this leveling bulb right here, okay, is raised up here to where the initial volume of the water in this leveling bulb and in this gas burette was at. As the reaction proceeds, nitrogen gas is produced and pushes the water down, 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 until we don't see any more bubbles going on in here. The reaction appears to have stopped. We then lower the leveling bulb down to wherever this level is, and it'll teeter-totter a little bit. But we get the leveling bulb down to the final volume of the the final volume of the gas in the bulb from the reaction. Okay. So initially, just pretend our initial volume was 2.2 milliliters. It was full of water all the way up to here. Then as the gas produced, as nitrogen gas was produced from the reaction, it pushed the water level down, 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 until when the reaction stopped and we got the leveling bulb at the same level as this. We had a final volume of 34.6 milliliters. So the volume of the nitrogen gas produced will be the final volume minus the initial, which would be 34.6 mils minus 2.2 mils, which gives me 32.4 milliliters. And to get the molar volume, I need to know the liters of nitrogen produced per mole. And that's because here, molar volume, that's V lower subscript M, that is going to be the volume per mole of whatever gas you're talking about. So I can take this milliliters and turn it into liters by dividing by 1,000. And then I take my 0.15 grams of sulfamic acid and turn it into moles of nitrogen, because I'm going to go from grams of sulfamic acid to moles of sulfamic acid using the molar mass of sulfamic acid added from the periodic table on a 1 mole basis. And then from the balanced chemical equation, I can see that here, I'll do it in red, for every 1 mole of sulfamic acid, I will produce 1 mole of nitrogen gas. So it's 1 to 1. So when I do this, I end up getting 0.001545 moles of nitrogen. So when I take the molar volume is liters per mole, I'm going to go 0.03240 which is the 32.4 milliliters converted into liters by dividing by 1,000. I divide it by the number of moles of nitrogen that made that volume, and I will get 20.97 liters per mole. That's the molar volume of nitrogen. But that's the molar volume when this lab happened to be, just hypothetically, at a temperature of 22.7 degrees Celsius. And the barometric pressure, the atmospheric pressure that day, measured with a barometer, is 742.4 millimeters of mercury. So in part 2, we're going to want to convert, okay, if it's 22.7, 20.97 at 22.7 degrees Celsius and 742.2 millimeters of mercury. Okay, that's a 2. What will it be at 0 degrees Celsius and 760 millimeters of mercury? And these conditions are STP, standard temperature and pressure. So in part 2, we're going to take this 20.97 liters per mole and figure out how to adjust it and find out what the molar volume would be at 0 degrees Celsius and 760 millimeters of mercury. Okay? Anyway, we'll go over that in part 2.